Digital twins may sound like something out of a science fiction novel, but the truth is, they're already revolutionizing the way industries operate today. This cutting-edge technology is no longer just a concept for the future, it's a powerful tool that's being used right now to drive innovation and efficiency across a wide range of sectors. At its core, a digital twin is a dynamic, virtual replica of a physical asset, process, or even an entire system, like a machine on a factory floor, a wind turbine in a field, or a complex production line. This virtual model is constantly updated with real-time data from its physical counterpart. Imagine being able to visualize a real-time, interactive model of your entire production line, right on your screen, with every movement, adjustment, and change instantly reflected in the digital world. This level of insight was once unimaginable, but digital twins make it possible. This living, breathing model uses a network of sensors and advanced software to mirror real-world operations in incredible detail, not just as static snapshots, but as a continuous, evolving stream of information. With digital twins, businesses can move beyond simply reacting to problems as they arise. Instead, they can predict potential issues before they happen, optimize performance, and make smarter decisions based on accurate, up-to-the-minute data. From the maintenance of jet engines to the management of entire city infrastructures, digital twins are bridging the gap between the physical and digital worlds, enabling a new era of connectivity and control. This technology empowers companies to boost efficiency, reduce operational costs, improve safety, and even extend the lifespan of critical assets by enabling smarter, data-driven maintenance strategies. In the chapters ahead, let's explore how digital twins are fundamentally reshaping maintenance strategies and transforming industries around the globe. Equipment failures can bring entire operations to a standstill, costing companies billions each year. When a critical machine unexpectedly stops working, the ripple effects are felt throughout the entire supply chain, from production delays to missed customer deadlines. Unplanned downtime leads to lost productivity, delayed deliveries, and damaged reputations. Customers may turn to competitors, and the financial impact can extend far beyond the immediate repair costs. Traditionally, companies have relied on reactive maintenance, waiting for machines to break before fixing them. This method often means scrambling to find spare parts and skilled technicians at the last minute, which can be both time-consuming and expensive. This approach often results in expensive emergency repairs and frequent breakdowns. The costs add up quickly, not just in terms of money, but also in lost trust and missed business opportunities. The unpredictability of failures disrupts workflows and increases stress for employees. Workers are left scrambling to adapt, and managers must constantly juggle shifting priorities to keep operations running. Over time, ignoring wear and tear leads to more frequent and costly replacements. The longer issues go undetected, the more severe the damage becomes, resulting in even longer downtimes and higher expenses. Clearly, waiting for things to go wrong is no longer sustainable. Modern manufacturing demands a smarter, more efficient approach to equipment management. Digital twins offer a smarter alternative by enabling early detection of potential issues. By simulating real-world conditions and monitoring equipment health in real time, digital twins empower teams to act before problems escalate. This shift to proactive maintenance reduces unexpected breakdowns and associated costs. It also creates a safer, less stressful environment for employees, and helps companies maintain a competitive edge. The industry is ready for this transformation. Embracing digital solutions is not just an option, it's becoming a necessity for long-term success. Digital twins start with real-time data collection from sensors embedded in machines. These sensors track parameters like temperature, vibration, and speed, feeding data to the digital twin. Advanced analytics and AI process this information, spotting patterns and predicting failures before they happen. Digital twins can also run simulations, testing what-if scenarios to identify root causes of problems. This allows engineers to understand and prevent failures before they occur. The combination of sensors, AI, and simulation makes digital twins a powerful tool for predictive maintenance. Companies gain actionable insights to refine their maintenance strategies. This technology is already making a tangible impact. Next, let's look at real-world success stories. Digital twins are already delivering impressive results across industries. A global automotive manufacturer saw a 30% drop in maintenance costs and a 40% boost in equipment uptime after adopting digital twins. In the UAE, a chemical company saved $2 million annually by predicting maintenance needs and avoiding costly downtimes. The aerospace industry uses digital twins to monitor jet engines, improving safety and reducing in-flight failures. These examples highlight how digital twins enhance efficiency, safety, and competitiveness. As adoption grows, more sectors are reaping these benefits. Let's dive into the key advantages digital twins offer. Digital twins deliver a range of benefits that transform operations. They reduce downtime by predicting failures, allowing maintenance to be scheduled during planned stops. This proactive approach cuts emergency repair costs and prevents expensive breakdowns. Early intervention extends equipment lifespan and maximizes return on investment. Enhanced safety is another major advantage. Predicting failures helps prevent accidents. Digital twins also optimize performance, providing insights to fine-tune processes and energy use. Companies can streamline workflows and boost productivity. These benefits make digital twins essential for modern industry. The result: smarter, safer, and more cost-effective operations. Now, how do companies put digital twins into action? Implementing digital twins in industrial environments begins with a thorough assessment of the facility. The first step is identifying critical assets. These are the machines and systems where a failure would have the most significant impact on production, safety, or costs. This process often involves collaboration between engineers, operations managers, and IT specialists to ensure that the right equipment is selected for monitoring. Once these assets are identified, IoT sensors are installed to collect real-time data. These sensors monitor variables like temperature, vibration, pressure, and energy consumption, providing a constant stream of information about the equipment's health and performance. The next phase involves building a virtual model, or digital twin, of the physical asset. Using advanced platforms such as Microsoft Azure Digital Twins, engineers create a detailed digital replica that mirrors the real-world equipment's structure and behavior. Data streams from the installed sensors are then connected to the digital twin. This integration allows for real-time monitoring and visualization of the asset's status. AI-powered analytics are applied to this data, enabling the system to detect subtle patterns and generate actionable insights. The digital twin system is configured to automatically detect anomalies, such as unusual vibrations or temperature spikes, and predict potential failures before they occur. This proactive approach helps prevent costly breakdowns. Maintenance schedules are then optimized based on these predictions, allowing teams to perform repairs only when necessary. This reduces unplanned downtime and extends the lifespan of critical equipment. To ensure success, employees are trained to interpret the data and use the new digital tools effectively. Ongoing education helps staff adapt to new workflows and maximize the benefits of digital twins. Careful planning and step-by-step execution are essential for a smooth rollout. Project managers coordinate with different departments to address technical, operational, and cultural challenges during implementation. The payoff is substantial: greater operational efficiency, improved reliability, and significant cost savings across the production line. However, the journey isn't without obstacles. What challenges do companies face along the way? Adopting digital twins isn't without hurdles. High initial setup costs, sensors, models, and AI can be daunting, especially for smaller companies. Training staff to use new technology requires time and resources. Data security is critical, as constant data flow demands robust cybersecurity. Companies must also manage the transition from traditional methods, fostering a culture of innovation. Change management is essential to ensure widespread acceptance and effective use. Addressing these challenges unlocks the full potential of digital twins. With the right approach, companies can overcome barriers and reap the rewards. So, what does the future hold for digital twins? The future of digital twins is bright, with rapid advances in AI, IoT, and cloud computing making them more accessible. Even small and medium-sized businesses can now leverage this technology for a competitive edge. Applications are expanding beyond manufacturing. Think healthcare, where digital twins of organs could help predict health issues. Urban planning is another frontier, with city-scale digital twins improving infrastructure and disaster response. As analytics and AI improve, digital twins will deliver even more accurate insights and sophisticated simulations. This will drive smarter, more efficient operations across industries. Adoption is set to accelerate, transforming maintenance and management worldwide. Digital twins mark a new era in equipment maintenance and management. Their predictive power saves money, boosts safety, and sets a higher standard for asset management. While challenges like cost and training exist, they're manageable with the right strategy. As technology advances, digital twins will become even more accessible and impactful. Their ability to turn data into actionable insights will drive innovation across industries. Embracing digital twins means unlocking new levels of productivity and sustainability. The future of maintenance is here, and it's digital.